Today's video takes a look at an important concept when working in the lab, and that is the idea of a dilution. Most chemicals in the lab are purchased and prepared as concentrated or stock solutions. A concentrated solution has more solute particles per unit volume. However, when working with these solutions, we typically want to dilute them down such that there are fewer solute particles per unit volume. So this idea of a dilution is taking the concentrated or stock solution and adding it to a diluent, typically that's water, and then using the diluted solution. So in order for us to do that, we need to use what is known as a dilution factor, which is the total number of unit volumes in which your stock solution will be dissolved in. And the formula for the dilution factor is the volume of stock solution taken divided by the final, also known as total, the final volume of your diluted solution. Okay. So this final volume is going to include the amount of stock solution that is used, as well as the amount of diluent that is used. So let's look at an example of how we calculate a dilution factor. Okay. So here I have a stock solution, and I want to take out 1 ml of this stock solution and add it to 9 ml of diluent. In order to figure out what type of dilution this will give me, I'll write out my formula for the dilution factor. And that dilution factor, again, is the volume of stock solution taken divided by the final volume. And remember that final volume includes the amount of stock as well as the amount of diluent. So my dilution factor, I'm taking out 1 ml of the stock solution, so in the numerator I will write down 1 ml, and divide it by 1 ml is going into 9 ml of diluent, so in the denominator that's going to be 1 plus 9 mLs, which gives me 1 over 10, which is the same thing as 0.1, which is the same thing as 1 times 10 to the minus 1. So we typically just write that as 10 to the minus 1. All three of these numbers are the same representation, but they're all showing that this dilution that I have just made has been a 1 to 10 dilution. I can also write that as a tenfold dilution. Let's try a second dilution problem. So here I have a stock solution again, and let's say this time I want to take out 0.5 mLs of stock solution and add it to 4.5 mLs of diluent. Again, to figure out what dilution this is, I'll start by writing out my formula. So the dilution factor is equal to the volume of stock taken divided by the final volume. Okay, and remember the final volume includes both the stock as well as the diluent. So I am taking out of my stock solution 0.5 mLs, so 0.5 will go in the numerator. And in the denominator, I have the 0.5 going in, as well as the 4.5 mils of diluent. 0.5 plus 4.5 mils. And when I calculate this out, I again will get 1 over 10, which is the same thing as 0.1, which is the same thing as 10 to the minus 1, which we can also write as a tenfold dilution. So taking 0.5 mLs of a stock solution and adding it to 4.5 mils of diluent gives me a 1 to 10 or 0.1 or tenfold dilution. And if you think about this, this makes sense because if you recall, the previous example we looked at was where I had my stock and I removed 1 mil and added it to 9 mils of diluent. Notice that the proportion is the same. Here it was 1 into 9. Here I'm just taking half and doing 0.5 into 4.5. So it's the same dilution. Let's try one more. And this one we have a stock solution. And this time I want to add 1 mil of my stock solution into 2 mils of diluent. To figure out the dilution, I again set up my formula. Dilution factor is equal to the volume of stock taken divided by the final volume. And the final volume, again, is the stock plus the diluent. I'm removing 1 mil, so 1 mil goes in my numerator, and the final volume is 1 mil plus 2 mils, so that gets me 3 mils. So this dilution is a 1 to 3, or we can also write that as a threefold dilution. We can use the idea of a dilution factor in figuring out how to prepare solutions in the lab. So let's take, for example, this problem. I want to make 30 microliters of a tenfold dilution of a stock solution in diluent. How would I do this? Okay. So the first thing is we look and we see we want to make a tenfold dilution. That means that my dilution factor is 1 over 10, or if you want to write it in decimals, 0.1, or you can write it in exponential form, 10 to the minus 1. So the dilution factor that I am interested in making should come out to a 1 to 10 dilution. Okay. So I'll write out my formula. Dilution factor, again, is the volume of stock divided by my final volume. And remember, final volume is the stock plus the diluent. So I know that this should equal 1 to 10. Well, I know that my final volume should be 30 microliters. Okay, so this is my final volume. So I can take this 1 to 10 and set it equal to X microliters of stock divided by 30 microliters. And if I cross multiply and solve for x, I will get that x equals 3 microliters. So in order for me to prepare this dilution of the stock, the first thing I need to do is take 3 microliters of stock solution. Now I have to figure out how much diluent to use. Well, I know that my final volume needs to be 30 microliters. Remember, final volume is the amount of stock plus the amount of diluent. So from my final volume, I'll subtract how much stock I'm using, minus 3, and that leaves me with 27 microliters. So in preparing this dilution, I'll take 3 microliters of stock solution and add it to 27 microliters of diluent. 3 microliters plus 27 microliters gets back the final volume of 30 microliters that I wanted. Let's try another problem. I have 50 mils of a concentrated solution of acid, and I want to dilute it down threefold in water. I only want 40 mils of diluted acid. How would I do it? Well, again, the first thing we need to do is look to find the dilution factor. Here, we want to dilute it threefold, which means that my dilution factor is going to equal 1/3. I set up my formula again, dilution factor, which is equal to the volume of stock divided by the final volume. Well, I know that my dilution factor should be 1/3, so that means that 1/3 is going to equal, now I need to figure out what my final volume is. If we look at the problem, it says I only want 40 mils of diluted acid. So this 40 mils represents the final volume. So 40 mils will go in here. And now I'm going to solve for how many mils of stock I need in order to make this dilution. I set up my proportion. I can then cross multiply. And when I do that, I will get that x equals 13.3 mils. So step 1 in preparing my solution is to take 13.3 mils of the concentrated acid. And you'll notice that I'm able to do that because in the problem I said that I originally had 50 mils. So 13.3 mils, you can get that from the original 50. I now need to figure out how much diluent to use. To do that, we go back again to our final volume. The final volume desired for this solution is 40 mils. I subtract how much of the stock I am taking. That's 13.3 mils. And when I do that subtraction, I get 26.7 mils. So to prepare this solution, I will take 13.3 mils of the concentrated acid and add it to 26.7 mLs of water. And in doing so, that will give me a threefold dilution.